this video, we're going to talk about two characteristics of a graph, zeros and continuity. We're going to start out by looking at zeros, and this isn't so bad when you have the graph and they're clear. They're going to get more complicated as we start to do them in the calculator, but for right now, a zero is anytime the graph crosses the x-axis, crosses or touches the x-axis. So if you're looking at Desmos on a graph of x squared, Desmos does a really nice job of telling you where the zeros are. So x squared as zero is anytime the graph crosses or touches the x-axis. So if we click on the curve, we can see that it's highlighting a point right here of 0, 0. So the only zero that exists for this function is the point 0, 0. Now anytime we are looking at zeros, it's always going to be an x coordinate, and then the y value has to be 0 because it's when it touches or crosses the x-axis. Touches or crosses the x-axis. So you can never have a 0 with a y coordinate of anything but 0. Okay, so let's just take a look at a couple other functions. If we go ahead and add a -2 here, so x squared minus 2, you see now that this graph crosses the x-axis twice. So x squared minus 2 has two zeros. One is at the point -1.41 comma 0, and the other one is at 1.41 comma 0. Now as we progress through the year, we're going to learn the importance of these values and the applications of them. But for right now, all you need to do is pull off where the zeros are located and know that it's where the graph crosses or touches the x-axis. So it is possible for a function not to have any zeros. If we looked at this absolute value graph of x minus 2 plus 4, you see that this curve now, it never touches the x-axis. So this is a situation where there are no zeros. Now if we change it to -4, that's going to shift the curve down, and now there's two zeros. One is at the point -2, 0, and the other is at the point 6, 0. Okay? That's pretty much it on the graphical analysis of zeros. The important thing to remember is just the y coordinate must be 0, and you're writing it as a point, and it's anywhere the graph touches or crosses the x-axis. So the next thing I want to talk about is continuity. So continuity of a curve. So we can say that a graph is continuous if you can trace the line and never have to pick up your pencil. If that is the case, then the graph is continuous on the interval of all real numbers. If you have to pick up your pencil at some point, the graph is not continuous. So the function that we currently have here, absolute value of x minus 2 minus 4, this is a continuous curve. You could trace this entire graph and never have to pick up your pencil. So we would say that the absolute value of x minus 2 minus 4 is continuous on all real numbers. Okay. Let's look at some examples where they're not continuous. So graphs are not continuous if there is a situation where there's a hole in the graph, there's a jump, or there's a vertical asymptote. So first, let's go ahead and look at the graph of x over x squared plus x. We're going to do x divided by x squared plus x. Okay, so as you can see in this graph, there's a vertical asymptote here. We can't start here and trace the entire curve. There's a vertical asymptote. X can never equal -1. So then If it does, there's a vertical asymptote there. So the graph is not continuous because it has a break. So we would say not continuous at x equals -1, because that's where that vertical asymptote is. That is restricting this graph from being continuous. Okay. If we had an equation that was something called a step function or a greatest integer function, which we will get to at another point, this is an example where there's jumps in the curve. As you can see, we go here up to this point and then we jump up, and then we trace, and then we jump up, and we trace, and we jump up. So this is not a continuous curve. I have to pick up my pencil to get from this point up. Okay, so that's a great example of jumping and not continuous. So another situation that you might see a non-continuity is if we had a graph, and we will get into situations like this, where it actually had a hole. At whatever this x value is here, there is no y value, so there's a break. This is called a hole. If that occurs, it's not continuous because we could trace the line, but we would have to pick up our pencil and then put it back down to get to the other side of the hole. So this is another example of not continuous. Right. So let's go back to Desmos and look at x to the 4th. Okay. X to the 4th, if I zoom out, you can see that it's continuous. There's no breaks. It goes on and on forever. So this would be continuous on all real numbers. If we looked at the graph of sine, again, you can see it's wavy, but I could trace this entire line up and down and up and down and up and down. There are no breaks, and we can look at any point along the line. Now, a graph like log of x, it is continuous, but not on all real numbers, because logarithms, you can never plug in into log of x. You cannot plug in 0. There's a vertical asymptote here, and then you can never plug in any negative numbers. So if we were looking on a domain of all real numbers, this curve would be not continuous. But we can say that log of x is continuous on a restricted domain. So it is continuous when x is greater than 0. So there are situations where, yes, the graph is continuous, just not on all real numbers. And when that does come up, you need to specify that our domain is restricted. So that was a brief intro on zeros and continuity. Take your notes, rewatch the video if you need to, and then come in to class tomorrow with any questions.